All right, we're working with day 5 today in our unit. Homework will be pages 26 to 27. And for your warm-up, I want you to try without looking at your sheet, see if you can write our 3 big reasons that imply parallelogram. We have more than 3, but there's 3 ones that come up most frequently in proofs. So go ahead, pause the video now so you can take a second to write those 3 down. And when it pops up, um, it'll ask for your answers. Now, they're all going to be implies parallelogram. So when you type in your answer, you can just type in the part that comes to the left of the arrow. And for symbols like congruent, parallel, you'll just have to write out the words for them. So go ahead, pause it now, and give the warm-up a try. So the one that tends to come up most frequently, one pair of sides congruent and parallel implies parallelogram. And the big thing is it's that same set of sides. So you can't do one set of sides congruent and then the other set of sides parallel. It's the same set of sides. And then the other ones are the both options for each of those. So both pairs of opposite sides congruent and both pairs of opposite sides parallel. And you could, if you wanted in this one, if you threw an opposite, that's fine as well. So if you see that we want to prove something is a parallelogram, these are the 3 most likely reasons you'll use at the end. Now, in saying that, the first one on the homework used one of the ones that is less likely. So let's take a look at that. So this first one on the homework, I would say this is a not as common proof. Okay, 2 and 3 on the homework were really common proofs. So if you struggled with one, not a huge deal. If you struggle with 2 and 3, then you want to definitely practice those ones some more. So in this one, we've got AECG we want to be a parallelogram. So that's that tiny quadrilateral in there, and we're given the big one already as a parallelogram. So our goal is, what we're going to do here is we're going to get both, we're going to get the diagonals bisect each other in the small parallelogram, which will imply that it is a parallelogram. So we're going to use some things that aren't that common. So they told us EF and FG are congruent. Well, because those are congruent, that means F must be a midpoint. We usually don't go in that direction. So we can say F is the midpoint of EG because we have 2 congruent segments, so it must be a midpoint. Now, the other ones, we're going to use the big parallelogram, and we're going to say parallelogram implies diagonals bisect each other. So we'll be able to say that DB and AC bisect each other. So then we know that F is the midpoint. By segment bisector implies midpoint. Now we can get F as the midpoint of AC and DB, but we only care that F is the midpoint of AC for the inside parallelogram that we want. So once F is the midpoint of AC, we had in step 3, F is the midpoint of EG, so we can say EG and AC bisect each other, because midpoint implies segment bisector, and then because the diagonals bisect each other, it implies parallelogram. So that should have been a tricky proof. Okay, if you had trouble on it, not a huge deal. 2 and 3 from the homework are the bigger deals going forward. So this was a really traditional having to prove a parallelogram. By traditional, I mean that often you have to get triangles congruent, and then do congruent triangles implies congruent corresponding parts to get the stuff that you need for the parallelogram. So we were given in the left and right triangles already 2 sets of congruent sides. So just do your perpendicular lines implies right angles, and then your right angles implies congruent angles so that we can do the triangles congruent. Side angle side is why they are congruent. Be careful to match up your letters, A with C, E with F, and D with B. Now, from there, our goal is to get AD and BC both congruent and parallel. then we'll be able to say it's a parallelogram. So we can do our congruent triangles implies congruent corresponding parts. That'll give us AD and BC are congruent, and right in the same step, say angle 3 and angle 4 are congruent, because those are angles for a zigzag, which will then allow us to get parallel lines. So once we have 3 and 4 congruent, we can do congruent alternate interior angles implies parallel lines. Well, now we have AD and BC both congruent and parallel, so we can say our one pair of opposite sides congruent and parallel implies parallelogram. So that is a pretty traditional proving a parallelogram proof. Similar difficulty level to what I would expect you to be able to do on the test for this unit. Okay, and 3, I would say, is a traditional difficulty level for one that you're starting with a parallelogram. Notice we want JX congruent to KX, so we want to think, let's get the triangles that have JX and KX in them be congruent. So you could really, because JX and KX are part of 2 triangles, I chose to get those smaller triangles congruent. You could have gotten these 2 triangles congruent and yielded the same result in the end. So it was just your preference. I chose the smaller triangles. So you want to do parallelogram implies diagonals bisect each other. Then segment bisector gives you a midpoint, and then midpoint gives you 2 congruent segments. So for my statements, that eventually led me to get PX and RX congruent. If you did it for the other triangle, that would eventually let you to get SX and QX congruent. From there, we want to do parallelogram implies opposite sides parallel. Now, I only did one set of alternate interior angles congruent in my next step, 6, 1 and 2. You could have done your zigzag going this way also and just got another set of congruent alternate interior angles, but for some reason I didn't do that when I wrote this proof out, so I did a vertical angles and got angle side angle. If you had done the other set of alternate interior, you would just have angle angle side. So multiple ways we could get to where we want to go. So you got your triangles congruent. Be careful to name your letters. P should match with R, J with K, and X with X if you did those ones. And again, like I said before, you could have done it with the other 2 triangles. And then we got our congruent triangles implies congruent corresponding parts. So this would be a very traditional difficulty level for one where you start with a parallelogram and have to prove something else. All right, we're going to go over to page 23. Today's topic is rectangles and rhombuses, and we're going to work with the properties of those to solve different things. And then tomorrow we will work with doing some proofs where we're given rectangles and rhombuses. On your green study card, you've got your rectangle and rhombus there. The rectangle and the rhombus each have all 5 of the parallelogram properties. And then the rhombus gets 3 additional properties. The rectangle gets 2 additional properties. So in the rhombus, the additional things we get is there are 4 congruent sides. So we know all of these are the same. We know that the diagonals bisect the angles. Well, angle bisector implies 2 congruent angles. So in the rhombus, all those will end up being congruent. Now, the reason all 4 of them are congruent is because from the parallelogram, big angle A and big angle C were already congruent, so when you bisect them, they should all be the same. And then similar idea, we would get those as well. So that's from that the diagonals bisect the angles. And then the last additional thing that a rhombus gives you is that the diagonals are perpendicular. So we have boxes on each of those angles there. Because the diagonals are perpendicular, sometimes you end up doing Pythagorean theorem with one of the small triangles in a rhombus because you have a right triangle there. So those are the new things you get for a rhombus in addition to the 5 parallelogram properties. A rectangle, you get 4 additional properties. One of them is that there's 4 right angles. So each of these big angles here would have a box. And then the other thing we have is the diagonals are congruent. So from E to G is congruent from H to F. And that's kind of hard to mark up in our picture because they're crossing, but that's a property that we get. On the bottom, we have kind of a flow chart. So you have the parallelogram first, which has the 5 properties that we've talked about the past couple days. Well, the rhombus and the rectangle are just more specific versions of a parallelogram. A rectangle is a parallelogram. It's just a subset of the parallelogram that has some additional properties. A rhombus is a parallelogram. It just has some additional properties that separates it from the ones that it does not. And then the square is also a parallelogram. The square has all of those 10 properties listed there, the parallelogram, rhombus, and rectangle properties. So if you have a parallelogram that has one property of a rhombus and one property of a rectangle, then you must be dealing with a square. So on your study card, part of what you want to do tonight is you should be starting to memorize those rectangle and rhombus reasons, because we will need tomorrow. Rectangle implies the two new things, and rhombus implies the three new things. So make sure to be studying those tonight and starting to memorize those. All right, so for each of these parallelograms, we want to choose the best name. But so what we mean by that is it just a parallelogram, or do we have properties that would lead us to know that it is a rhombus, rectangle, or square? So we want to basically see, as we move down our chart, what's the most specific one we can name it as. And then we want to find all of the measured angles. So let's find the measured angles first. So we've got these markings here, so these are each isosceles triangles. So let's list out angle 1, angle 2, angle 3, and angle 4. Because it's isosceles, the base angles should be congruent. So we know angle 3 has to be 54. Then we've got three angles in a triangle, two of them are 54. So we know 54 plus 54 plus x has to equal 180. Well, that's 108 plus x equals 180. And when you subtract it over, that's x equals 72. So we know angle 4 here has to be 72. Well, these were parallelograms, and something we know about parallelograms is that opposite angles are congruent. So that means angle 1 has to be 72 degrees. Oops, I wrote my 72 in the wrong spot for the 2. We haven't found 2 yet. This should go down here for angle 4. All right, well, if this angle 1 is 72, and notice you've got the 2 marks, so that's isosceles, well, then it must be just like the other one, and these are each 54. So angle 2 would be 54 degrees as well. So we really did part B first. We found the measures of the angles. So we know it's at least a parallelogram. We need to see if we can get more specific. Well, the angles, the big angles, are not 90 degrees, so that rules out rectangle. But a couple things we should notice is that all 4 sides are congruent. And also notice that that one diagonal is bisecting the angles. It's the same thing on each side. So that's telling us some rhombus properties, so therefore we know this is a rhombus. For the next one, let's write out our angles. So for angle 3, we have vertical angles. So 3 has to be 106 degrees also. For angle 4, those are angles on a line, so they have to add to 180. X plus 106 must equal 180. When you subtract the 106 over, we get that x is equal to 74. Well, let's pause right now, and before we do the other 2 angles, we should be able to name our figure. It's got a right angle, so a parallelogram with a right angle has to be at least a rectangle. To determine if it's a square, it needs to have a rhombus property. Well, notice we've got the angle where our diagonals cross is 106. So because we don't have a right angle at the diagonals, and in the rhombus, the diagonals have to be perpendicular, that means we know it doesn't have a rhombus property. So it only has a rectangle property, so it can't be a square, so it's just a rectangle. Knowing that now will help us for angles 1 and 2, because we know angles 1 and 2 have to add to 90. Some other things we know is the rectangle's diagonals bisect each other. So, and that they are congruent. So because they bisect each other and are congruent, all those things are the same. Well, this triangle on the left now must be isosceles. Isosceles triangles have congruent base angles. So imagine we called those base angles x. We would have x plus x plus 106 has to equal 180. Well, if you subtract the 106 over, we'll now have 2x equals 74, and divide by 2, and we get x is 37. So x represented our base angles there, so angle 1 is just 37 degrees. Well, to find angle 2, we knew that together they had to add to 90 degrees. So if we do 90 minus 37, that will give us 53 degrees for angle 2. And our last one, we'll do our angles 1 through 4. So we have that this is a parallelogram already. So something we can use is our parallel lines and do the zigzag. By our congruent alternate interior angles, we would know angle 2 has to be 30 degrees. Well, we can do our zigzag going this way to know that angle 1 has to be 60 degrees. Well, let's see if we can name our figure now. 30 and 60 gives us 90, so we need to know it's at least a rectangle. If it also has a rhombus property, then it would be a square. But the rhombus, the diagonals bisect each other. And these diagonals are splitting into angles of 30s and 60s, so they don't bisect each other. So this is just a rectangle. What we mentioned in the last one, diagonals are congruent and they bisect each other, so these are all the same. So we have all isosceles triangles there. Isosceles triangles have congruent base angles, so angle 3 must also be 60 degrees, and angle 4 must also be 30 degrees. All right, so we're going to tell whether these can be parallelograms or not with the marked information. So we have opposite angles marked as congruent. So yes, this is possible because we have that a parallelogram implies opposite angles congruent. Okay, so it is possible for that to happen. So in this next one, could we possibly have this scenario that those two angles are the same? Well, this could happen if we're dealing with a rhombus, because in a rhombus, the diagonals bisect the angles. So that scenario could occur if it's a rhombus, and a rhombus is a more specific parallelogram. So we can say yes if it is a rhombus. Moving to the last page for today, page 25, we're going to look at some algebraic problems. If you're not given a picture with these, it's always good to draw a picture. So we have HIJK is a rectangle. So let's draw a rectangle, and we'll label it HIJK. Oops, HIJK. And they tell us values for HJ and IK. So those are our diagonals. So there's HJ and there's IK. Well, if we have a rectangle, let's think about what we know about our diagonals. From the parallelogram properties, we get the diagonals bisect each other. From the new rectangle properties, we get the diagonals are congruent. So that's the one that's going to tell us the equation to set up. We know that the diagonals are congruent, so we can set those two things equal to each other. We'll solve for x. Maybe we'll subtract the 3x over first, giving us 5 equals 2x minus 9. Then we'll add the 9 over next, working to get x by itself, so that will give us 14 equals 2x. And then if we divide by 2, 7 will equal x. In this course, when you find x, always reread the question, see if that's what they wanted. Find the value of x, yes, but then we wanted to find the length of each diagonal. So off to the side, let's do hj equals and ik equals, and we'll fill in. We'll have 3 times 7 plus 5, and we'll have 5 times 5, or sorry, 5 times 7, because 7 was our x, minus 9. Well, 3 times 7 is 21, and 21 plus 5 gives us 26. 5 times 7 is 35, and 35 minus 9 also gives us 26. So that makes sense because they should have been congruent. Well, in part B, we can use the same picture. They just give us something for hj and ik again. So if you did part A correct, you should probably be able to do part B correct. So we'll set those equal to each other. Maybe start by subtracting the 2x over, which will give us 19 equals x plus 22. We'll subtract the 22 over, and that's going to give us negative 3 for x. So we should be concerned a little bit that x is negative. We're dealing with segment lengths, which need to be positive. But as long as it gives us back positives for hj and ik, then we'll be okay. So let's sub them in just like we did before. In this case, we'll have 19 plus 2 times negative 3. And for ik, we'll have 3 times negative 3 plus 22. So this will give us 19 minus 6, which is 13. This will give us negative 9 plus 22, which is also 13. Makes sense that they should have been equal. And our last one for today, they're telling us that we have a rhombus. So as soon as they tell you it's a rhombus, we want to think, okay, we got the 5 parallelogram properties. Those are opposite sides congruent, opposite sides parallel, opposite angles congruent, diagonals bisect each other, and then consecutive angles supplementary. And then we have the 3 additional rhombus properties, that all sides are congruent, diagonals bisect the angles, and diagonals are perpendicular. So having all those properties memorized are important. That's what allows you to do the problems, whether it's an algebraic problem or a proof problem. So because we have all of those, the easy angle probably to get first is angle 2. We know the diagonals are perpendicular, so angle 2 has to be 90 degrees. Now angle 3 and 4, because diagonals bisect each other, we know 3 and 4 have to be congruent. So if we can find one of them, we'll be able to find the other. But probably the next easiest is to find angle 1, because we have 2 of the 3 angles in that triangle there. So we can do 20 plus 90 plus x is equal to 180. That's 110 plus x equals 180. Subtract the 110 over, and we get for angle 1 that it's 70 degrees. Well, rhombus has the parallelogram stuff, and parallelograms have parallel lines. So when you do your zigzag, we have alternate interior angles congruent. So 1 and 4 should be the same. And we said 3 and 4 should be the same based on the fact that diagonals bisect the angles. So that's part A. We found our angle measures. Part B, is they tell us AC is 8 and BD is 22, so we want to find the area. Well, diagonals bisect each other, so if AC is 8, that means this is 4, and this is 4. And if BD is 22, that means that's 11 and that's 11. Well, all those triangles have the same measures for sides. So we can do an area of a triangle, which is 1/2 base times height, so 11 times 4. And then we can take that and multiply it by 4 because there's 4 triangles. Well, 1/2 times 4 is 2. 2 times 11 is 22. So this is 22 times 4, which is 88. And it's an area, so we would have units squared. Now we did see a shortcut rhombus formula earlier in the year, diagonal 1 times diagonal 2 over 2. So that would just tell us we have 8 times 22 over 2. Well, 22 divided by 2 is 11, so 8 times 11 is 88. So we could have used that if we wanted, but my guess is most people don't remember that. It's just a really brief thing that we talk about this year, and we've done lots of areas of triangles, so it's probably easier to just do the area of one of the triangles and then multiply it by 4 because they're all the same. That's it for today's video. Have a great rest of your day.